This is the Unit 5 review guide for ELR 5.5. The questions look like this. For number 14, the question is asking each arrow represents a process. You need to name each one. I'm going to start on the one on the left. We're going from a solid to a liquid, so this is going to be melting. And then it goes from a liquid up into a gas. And in this case, we're going to be talking about boiling. There's a big difference between boiling and evaporating, which I'll talk about in just a second. Over on the right side, we're going back down. We're going from a gas down to a liquid. This one is called condensing. And then from a liquid down to a solid is freezing. There are two on here that aren't labeled, and so I want to add those in, and I'd like you to do the same also. When a gas goes down to a solid, this is called, I'm going to turn it sideways, this is called deposition. D-I-O-N. And when a solid turns into a gas, with skipping over the liquid phase, this is called sublimation. Okay, number 15. How is the left column different than the right column? Well, on the left column, what's happening is energy is being added at each step. So on the left, energy added. And then on the right-hand side, it's the exact opposite. In order to go from a gas down to a liquid and then down to a solid, or to go straight from a gas down to a solid, on the right, energy removed. For number 16, what happens to the molecules when a liquid freezes? When a liquid is freezing, there are a couple of things that happen. The molecules will slow down. Bonds get made. And energy is taken out, so energy removed. What does the freezing point mean? Number 17. The freezing point is the place where the temperature of a liquid the freezing point is the temperature when the liquid becomes a solid. So it's that spot on the graph where if you have a liquid, the temperature is dropping, and then it flatlines and then goes back down. It's this whole section. The freezing point is this spot on the temperature graph. So if that's temp, it's right there. So put this in words. It's the temperature at which a material, or I should say specifically a liquid, becomes a solid. The last one, how are deposition and sublimation different from the other four types? Well, in both of those cases, they skip right over the liquid phase. And the way that they do this, and this is the part where I'm just going to scoot that out of the way, if you imagine a graph like this, and on the bottom is the kinetic energy, and then on this axis you put the number of molecules. I want you to imagine for a second all of the molecules inside of a solid. In a solid, in any material, all of the molecules aren't going to have the exact same kinetic energy. So some of them, if let's say the average is like right here, some of them are going to be on the left, some of them are going to be on the right, and there's going to be this big spread with the peak being right around there. And it's actually going to have this really long little tail getting closer and closer to zero. Well, let's say that this represents the amount of energy in order to make a liquid. And this represents amount of energy to be a gas. Well, most of the molecules are stuck down here with too little energy, or in other words, not enough energy, to be turned into a liquid phase. Some of them are, those are the ones right here, but because a liquid is still pretty compacted, the ones that are able to turn into a liquid are so close to the solid that they'll probably be turned right back into a solid shortly thereafter, and they'll stay close enough and you probably wouldn't even notice a change. But the part that's most interesting on this graph is the part out here that I'll outline in red. It's this really skinny section out here. very, very few molecules, but still some, in a solid have just enough energy to turn into a gas. Well, because a gas is really spread out and the molecules can move freely away from the solid, these molecules, even though there are very, very few of them, when they turn into a gas, they can go away and not get turned back into a solid. This is where the sublimation comes from. Those are molecules being turned from a solid into a gas. If you had another graph like this, and there's my energy required to turn into a liquid, there's the energy required to turn into a gas. If you have a gas, same idea. There's this little section way down here that has just enough, or just low enough energy to turn into a solid, and that's exactly what they do. So this would be the opposite. This would be deposition.